Welcome to solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
We'll be considering equivalent force and couple moment. I want to find those for F1 and F2. We also look at find the resultant couple moment or the couple moment. Now, what we can do to solve this problem is to add the F1, the components of F1 to the components of F2. Just sum them together, okay, based on their IGK directions to get the first part, which is the equivalent force. Then for the couple moment, we need to get the position vector based on each force, multiply that force with the position vector, and sum it with the one for the other force to get the moment we are talking about, the couple moment. So we know that F1 from the question, okay, F1 has no component in the I direction, as you can see from the diagram. Okay, so in the I direction it has no component in the J direction, but it has is negative, okay, negative 40, okay, in the K direction. So that's that for this force, okay, in Newton. Now we have F2. If you look at F2 is inclined to an angle, okay. Let's just bring at the angle, something like this, to 45 degrees, okay. So this is F2, and this is 45 degrees, okay. It's inclined to 45 degrees. So what we can do to is to resolve this. When we resolve this, we are going to, this side is going to be, sorry, let me just okay, this one coming like this, and this one going like this. So when we do this, we are going to have this side to be F, okay, F2, because this is F2 sine 45, okay, sine 45 degrees, and this side is F2 cos 45 degrees, okay. When we solve this, we are going to arrive at this one to be minus 28.3 Newton, okay. And we are going to arrive at this one to be equal to minus 28.3 Newton. So we can bring it in here now. You can see that it has no x. If you check the diagram, it has no, in the I direction, there's nothing there, okay. So we have this one, then minus 28.3 I j minus 28.3 K Newton. Okay, you can sum them now to get the resultant force that we are talking about, the couple moment rather that we are talking about. So when you sum them together, you're going to have minus 28.3, 28.3. Since there's no I direction, so what we have is J. So for the I direction is 0. So we just leave that out. Minus 68. So when you sum 28.3 and 40, you're going to have this K direction. Sorry. This is K direction, K. And everything is in Newton. So that about, okay, it's in Newton. All right. Now, having known, so that this is the equivalent force we are talking about, okay. Now let us look at the other part of the question. The other part of the question, they want us to find the couple moment. To do that, we'll look for their position. We know that for F1, the position of F1 is at 0. If you look at it in the x direction, is 0. Then if you look at it in the y direction, it's actually towards the right, okay, along the positive side of the y, and is acting at the radius along the y direction of the pulley. So it's 0.08 because the radius of the pulley is 0.08 meter. Okay, then it has no height, so it's 0. So this is define the position for F1. So that if you consider the point A, look at point A. Point A, if you look at point A is at 0.3, okay, 0, 0. So if we do our subtraction to get our arrow one, okay, to get the position vector, okay, you're going to have something that look like for arrow one, it's going to give you minus 0.3, okay, 0.3 I, okay, when you just sum them, plus 0.08 based on the IJK direction. Just do your sum based on the IJK direction, then plus 0 the I in the K direction. Okay, you're going to have something like that. Then follow the same pattern, okay, and do for arrow 2. So if you do for arrow 2, you are going to arrive at minus 0.3 I minus, of course, we don't know the other part of J, the other part of R, the other complex. So what we can do, we know that the force is inclined. If you look at it, it's inclined to that angle 45 degree. Look at it there, okay? And acting at that point. So what we can do, we can bring it out so that we have something that look like this. Okay. Sorry, something that look like we have something that look like this. Okay. Okay. This is the point where it is. You can see that this place is up towards the Z direction. Okay. This is up towards the Z direction. Sorry. This is up towards the Z direction, and this is towards the Y direction, something like this. Okay, in the negative Y, this is positive Z direction. Okay, and so this is point where we have point 0. Okay, where the force is acting on the tilted at inclined at 45 degrees, where we have the pulley and to the other. Okay, now if we do that, we know that if we look at how this place is arrow, okay, the radius of the pulley, okay, to 15 degrees, 15 degrees, sorry, 45 degrees. Okay, so when we do that, we are also going to look for F2. Okay, this one will give us F2. Sorry, for F2, this side is going to give us arrow cos 45 degree. This part of F, okay, is going to give us this radius. So for this side, we are trying to look get the distance. Okay, it's going to give us arrow cos 45 degrees. Okay, while this side is going to give us arrow sine 45 degrees. Now when we sum this up, we're going to have our value. Okay, this side is going to give us equal to 0.045 0.057. Okay, that's what it's going to give us. While this other side is going to give us the same thing. Okay, it's going to give us going to be equal to 0.057. Now let's fix it in now, or fix them in rather. Now for the J component, you will now see that the J direction rather is towards the negative side. So our 0.057 is going to be negative. So it's going to be negative 0.057. And it's going to give us positive because this is where we have zero and it's up. Okay, this distance is up. So it's going to give us 0.057. Okay, positive in the K direction. So these are what we are going to have as our position vector. So we can now apply this into the map into so that our moment that we are talking about, so the resultant, the couple moment at A is going to be equal to R1 times F1, which we already know, plus R2 times F. Okay, F2. So when we do that, we can use matrix to solve it so that we now have the I, J, K directions. Okay, for F1, we're going to have it to be minus 0.3. Looking at the position vector, then 0.08, okay, and 0. Then for the vector, for the force, we have 0. Based on the force, we have 0, 0, minus 40. Okay, then plus this other one, I, J, K. We know that for this second one, the F2, when we subtract, in fact, we've already gotten it already. We are going to have it to be minus 0.3. The I direction is there already. Just plug them in. Minus 0 point. We brought them out already. Just arrange them. Okay. Then this side is positive 0.057. So we can now bring in the force, which we've already calculated. We've done before. Minus 28.3 minus 28.3. Okay. So you have this. So when we sum them together, okay, when we use metrics to use apply matrix, okay, uh, principles, you arrive at your M, okay, resultant couple moment at A to be equal to minus 20.49 J, 0.49 J plus 8.49 K, and of course is in Newton meters. So that is our answer. That's the answer, couple moment.